This example is slightly different than example number 1. Again, we're talking about forces, but now you can see that I'm dealing with more than one force. I'm talking about a horizontal force of 100 newtons applied. I have a force of friction in here, so you can see there's multiple forces. To try to keep this pictured properly, you might want to draw yourself a sketch and label the forces. Now, it doesn't tell you what direction these forces are, and same with example number 1. You'll notice that I didn't label a direction because it didn't say north, east, south, or west. It's just asking for the magnitude anyway, so it's not asking you to specifically tell me a direction. But again, if you were dealing with a vector, it should include a direction where possible. So when you look at this question, first thing I'm going to do is draw my object. It's sitting on a level surface, and there's a 100 Newton force being applied to it. So I'm going to go in one direction. The applied force is 100 newtons. It's also key to remember that friction never acts to speed objects up. Friction always acts to slow objects down. So if your applied force is in one direction, your friction force should be in the other direction. And notice I drew my friction force smaller because it is a smaller value. These are vectors, so I'm drawing a direction with them as well. So my applied force is 100 newtons. My friction force is 20 newtons. There's a normal force acting on this object. There's a force due to gravity acting on this object, but it's not really referring to those. So I'm just going to draw the forces that are relevant to the question. Of course, you could draw the other forces on it if you want, and maybe there will be another question where you need it, but not in this case because the force due to gravity and the normal force on a level surface are equal and opposite, so they cancel out anyway. Had we been on an incline, which you'll see in some later questions, in a few lessons down the road, then we'll include those. But I tend to only put the information that I need. I also know the mass of the object, so I'll put that down here, 10.0 kilograms. And I also put down what I'm looking for. They want to know the acceleration in this question. Now this is one of the most important skills that you have to remember. Newton's law always wants net force into that formula. Do not put applied unless the applied force is the only force like example 1. Do not put force of friction unless force of friction is the only force like example 1. Or, well, example 1 didn't use friction, but it was an only force. So if you're going to use that net force formula, if you want to find the acceleration, we know that acceleration equals F net over m. We just finished using this formula. It's a very popular formula. So if we could figure out the net force, then we can divide it by mass and find the acceleration. Well, in this case, to find the net force, because these arrows are in opposite directions, we're going to subtract. Had the arrows been in the same direction, we would add to find the net force. So the net force in this case, and that's where the diagram really helps. This case, it's going to be our applied force, which is the larger force, subtract the force of friction, divide that by the mass of the object. Now, notice that if the force of friction was greater than the force applied, the object wouldn't accelerate. So since the applied force is larger, we are going to see an acceleration. Should make sense to us in terms of just logic, that if you apply enough force, you'll overcome friction, and that's why the object will slide. Same thing as when you push an object, a box along a carpet, requires a lot more force because there's a lot more friction than if you slid it along a linoleum floor. You know, it's a little less friction on there. So the friction force depends on your surface. If you can put your numbers in here, acceleration equals, we have 100 newtons, subtract 20 newtons, for the friction. And what we want to do is divide that by the mass, which is 10.0 kilograms. And the acceleration can be written in newtons per kilogram, or we can use the more common term meters per second squared. So we end up with 80 over 10. And again, we check back to our question here. I have 3 sig digs in the question. Actually, my answer should be written a little bit more properly. It should be written as 8.00 meters per second squared. I don't have the right number of sig digs in the solution in brackets here. I should be going to 3 significant digits in this question.